Hello folks, welcome again to our lesson. This is SPSS. What is that? Student Problem Solving Session. This is a scenario where I show you how to apply knowledge learned in question form. So we are targeting calculating U, V, and A. A reminder, speed is found in velocity. In what sense? That figure that you calculate is basically speed. When I talk of velocity, it means that speed was attained in a particular direction. Okay? So what are we doing here now? Remember, I'm using ticker timer. A ticker timer has a tape. On that tape, there are dots. So those dots are the ones we are using to study the motion of a trolley. Basically, a trolley moved in a particular direction. So I can talk about speed and velocity interchangeably. Therefore, we need to understand this tape. We need to understand that tape. This tape has these dots. These dots are the ones I am using to study. They are close together and then they are spaced. This is just a small piece, but the piece that is used in a ticker timer can be very long. I'm only using this for demonstration. Suppose I have this piece. Then I have shown you the distances between A and B. You remember, this is the same tape I used in lesson 2. I've used it now, but with a modification. That a point like A, that first dot is our reference point for getting measurement. So from point A to point C, I've measured and it is 1 centimeter. And from point F to point G, I've measured it is 4.7 centimeter. Which question may follow? 1. How do you get the initial speed? Speed is distance divided by time. The distance already has been given as 1 centimeter between point A and C. Then I have to ask myself, what was the time taken to cover the distance AC? Remember, AC is made up of 2 spaces. One space is here, and this is the second space. We are working from understanding that the frequency of this timer is 50 Hz. 50 spaces were made in 1 second. So time for one space, is equal to 1 over frequency, which gives us 0.02. Okay, this is 0.02. Okay, that is time for one space. Now, if I substitute in my formula, this one you can call it initial speed or initial velocity. Initial speed deals with figures. The same figures will be applicable in velocity. The difference is, if you talk of initial velocity, in your mind, you know the trolley was traveling in a specific direction, which is the case. So when I talk of speed, there are those figures, numbers. When I talk of velocity, I have the same figure, but at the back of my mind, trolley traveled in a specific direction. So distance is always given, or directly, or by use of scale. In my case, it has been given directly. Then time, you can see I've written here 1/50, time for one space, but I have how many spaces between A and C? 2. So I multiply 1/50 times 2. When you compute this, you get 25 centimeter per second. This figure 25 is what we call speed. It is a figure. Velocity is made up of two components, the same figure and direction. What about V, final velocity? I take it from the end of my tape. The distance that has been given is between F and H. That is 4.7. I have to come and get what time did the timer take to cover the distance FH. FH is made up of two spaces. Therefore, I write 1/50 times 2. Why 2? Because I am dealing with two spaces. When you compute this, you get 117.5 centimeter per second. So that is how I get initial speed and final speed, or initial velocity and final velocity. If I want to calculate acceleration, I use the formula rate of change of velocity. Rate of change of velocity. Remember, there is velocity change over time taken. Which is this time? The time from initial velocity to final velocity. When you substitute, you can get the V 117.5 minus U, which is 25, divided by time taken for that change, which I symbolize as TA. TA, time for that change. Now I want you to get it right. Time change starts at the center of U to the center of V. The center of initial speed to the center of the final speed. The center of initial speed is at B, and the center of the final speed is at G. How many spaces are there from B to G? We can count all of us. 1, 2, 3, 4, 5. So I write TA, time for that change, time for this acceleration, is one space, time for one space, times the number of spaces. When you compute, 5 goes into 50 10 times. So 1 over 10 gives me 0.1. Now, you can conclude A is equal to 117.5 minus 25 divided by 0.1. The answer you get will be centimeter per square second. If they ask you to give your answers in SI unit, you just change at this final level. Okay, you change at final level. So I want you to compute this in both centimeter per square second and then meter per square second. I want to move on to another version of asking for acceleration. This version is a piece of tape like the one I've shown. Let us look at the second version. I'm focusing my camera down now. I'm sure we can get it right here. Down there, I think everything is in the camera now. You can be given many pieces for that tape. From that tape, we can cut 10 dots. The initial 10 dots, the following 10, and so on. So from that single tape, from that single tape, we can count the dots. For example, 1, 2, 3, 4, up to 10, you get a piece. And then 10 spaces, get a piece. Then 10, a piece. Okay? So we have 10 spaces. 10 spaces from a single tape. Then we arrange them as shown. The first tape here, the next, and so on. Okay? In my case, I have used 6 pieces. I've used 6 pieces. Each piece gives me the distance according to the vertical scale, which is labeled displacement in centimeter. So this is the scale. You can see the initial tape here, which has 10 spaces. Each has 10 spaces. Each tape has 10 spaces. So the first tape has a height of 2 centimeters. That gives me automatically the length of the 10 spaces. The last tape is here. Its length is 12. If I may assist you, this, that, and of course the first one can be seen clearly. So we have the length of the first tape, which will be used to give me initial speed. It is 2 centimeters. The last tape has a length of 12 centimeters. So in as far as initial speed and final speed are concerned, I know their distances. The next thing is to know the time. What was the time taken to cover these 10 spaces? You will do 1 over 50, then multiply by the 10 spaces. 1 over 50 times 10 spaces. 10 goes into 50 5 times. So essentially, I'm talking of 1 over 5, which is 0.2. When you put 2 as distance and 0.2 as time taken to cover 10 spaces, you will get the first step gives me initial speed of 10 centimeter per second. The last step will give us the final speed or final velocity. The distance can be read from the displacement axis. I come and find out how long did it take to cover the 10 spaces of the last piece. Again, time for one space is 1 over 50. If I want time for 10 spaces, I'll do 1 over 50 times 10, which gives us still 0.2. So when you put distance 12 divided by time taken to cover 10 spaces, your final speed comes to 60 centimeter per second. A big concentration is required now. If I want to calculate the acceleration, I told you is from the middle point of initial speed to the middle point of the final speed. Each tape shown here, each piece has 10. So this is 5 and 5. Then these ones are 10, 10, 10, 10. And then here I have 5 and 5. So it helps us to calculate time taken for velocity change. Velocity change starts from the middle, meaning that I leave 10 spaces, I work with 5, add to 10, add to 10, add to 10, add to 10, and then you have 5. Then leave the final 5. So how many in total? Let us work with the blue first. These are the core of the question. So in between the first step and the last step, in between the first step and the last step, there are 40 spaces. From the first one, I work with only 5. Remember, it is from the middle of this to the middle of the final tape. So I work with 5 here, and I will also work with 5. So I have 5. I have also here 5. So the blue are the spaces I'm going to consider. 1, 2, 3, 4, 40, 45, 50. So I've left out a half on the final piece and also a half on the initial piece. So time for one space is 1 over 50, and I'm dealing with 50 spaces to give me a time of 1 second. Now I have 3 major components: U, V, and TA. Time for velocity change, I'm symbolizing it as TA. So come here. Acceleration is equal to V minus U. This top can also be asked, what is the change in speed or change in velocity? Remember, you answer it. If it is speed, it is that figure. The difference between 60 and 10 If I ask you for change in velocity, you will give me 60 minus 10, which is 50, but you will add the word in a specific direction. In a specific direction. That change from 60 to 10 was in a specific direction. The trolley, when you release it on an inclined plane, it will not move in a zigzag manner. It will move in a specified direction. So be careful. You can be asked, what is change in speed? You deal with figures. If it is velocity, it is in specific direction. So if you substitute V, U, and TA, you end up with 50 centimeter per square second. If he asks you to give your answer in SI unit, now you just do 50 centimeter, convert it into meters. Okay, you convert it into meters. That is, you divide by 100 and you will get the answer 0.5 meter per square second. Folks, these are the two possible ways in which a ticker timer can be asked. Remember, you must know the frequency of the timer. Frequency of the timer, its reciprocal, gives you time taken to cover one space. A challenge to students is to interpret the time taken from U to V. Remember, it is the middle of U to the middle of V. You count the spaces there, multiply by 1 over F. F can be given as 50 Hz or 100 Hz. So be careful to know what is the frequency given. Folks, you need to try this on your own. You have to play this tape twice or thrice, then internalize. There is nothing like magic here. It boils into concentration, self-drive, and determination. Please subscribe so that you get a notification for another. There will be another SPSS to concretize the application of the formula. Till then, bye-bye.